SCH4C, determining chemical formulas. Part B, Lesson 12, Empirical and Molecular Formula. Number 1. The ratio of hydrogen to oxygen by mass in water is. To do this, we want to first of all calculate the molar mass of hydrogen, and we have 2 of them. So we have 2, and if we look on a periodic table, that's equal to 1. Then we have the molar mass of oxygen, and if we get that from our periodic table, it is 16. So we have a 2 to 16 ratio. That can be simplified to 1 to 8. So our answer is D, 1 to 8. Number 2. A possible molecular formula for the compound CH2O is. Now, we have CH2O. This is a 1 to 2 to 1 ratio. Let's look at our results. So C2 to H4 to O2. Now that can simplify down to 1 to 2 to 1. It's correct. Now, we have in part B 3 to 6 to 3 is also 1 to 2 to 1. Here we have 4 to 8 to 4, which is also 1 to 2 to 1. So all of the above are correct. Question 3. The percentage of nitrogen by mass in nitric acid, HNO3, is... Alright, so we want to start by doing the molar mass of HNO3. We know H is 1, we know N is 14, and we know oxygen is 16, and we have 3 of them. So this adds up to 63. But we want nitrogen. So nitrogen is 14 divided by 63, and it's a percent, so we multiply by 100, and that works out to be 22.2%, which is D. Now, number 4. The percentage of oxygen by mass in calcium hydrogen carbonate, CuHCO3 2, is... Now, again, we will start by determining the molar mass of CaHCO3 2. Ca is 40, hydrogen is 1, carbon is 12, oxygen is 16, and we have 3 of them. Okay, so this is going to be 48. Now, we have 40. We have 2 times 1 plus 12 times 1 plus 12, and then we have plus 2 times 48. And this works out to be 2 times 61, which is 122. So we have 122 plus 40, which is 162. So now we are going to take our oxygen, which is going to be 6 times 16 divided by the total, which is 162, and our answer is B, 59.2. Now I'm going to let you try number 5 on your own. You could pause the video. You should get A, 14.9% as your answer. Okay, then we're going to now do number 6. And so we want the percentage composition of chlorine by mass in the compound K2PtCl4. So again, we start with finding our molar mass. K2 is 2 times 39.10 from your periodic table. PT is 195.08. And chlorine, and you have 4 of them, is 4 times 35.45. So we have 78.2, 195.08, and 141.80. Now that's going to add up to 415.08. Now, chlorine was 141.8, and we want the percentage composition. So we're going to take 141.8 divided by the total times 100, and we will get the answer of 34.2%. And that is your percentage composition. Number 7, I'm going to let you do that, and you should get the answer A. And I'm going to let you do number 8. Your answer should be 35. Now let's take a look at number 9. A 100-gram sample of a compound is made up of 35.9 grams of aluminum and 64.1 gram of sulfur. The empirical formula of the compound is, so step number 1, list the given values. So we know we have aluminum, and we have 35.9 grams, and sulfur we have 64.1 grams. Now, number 2, calculate the mass of each element in a 100-gram sample. So we are going to take 35, we'll start with aluminum. 35.9 grams divided by 100 grams. We want this as a percent, so we're going to get 35.97 grams, because this will cancel. Okay, now we have our sulfur. And if we take 100 grams, we have 64.1. So 64.1 grams divided by 100 times 100, and that's going to be 64 grams. Okay, so as a percent, aluminum is 35.97%. and sulfur is 64%. And this was really step 3. And in step 3, what you want to do is take your percents and now convey the mass into an amount. So we have for aluminum, I'll put this over here. So aluminum, we have 35.9 grams, but its value is 26.98 on your periodic table, and that's going to work out to 1.33 mole. And then we have 64 divided by 32, which is going to be 2 mole. So this is step 4. So this is your amount ratio. So we have a 1.33 to a 2. And this is your amount ratio. Now, the next step is over here. I'm running out of room. We have 1.33 over 1.33 to a 2, and we also put that over 133. So that's a 1 to a 1.5, which is equal to 2 to 3. So this gives us our final answer of 2 to 3. Now, next question, because those are similar, is what is the molar concentration of 0.2% mole potassium hydroxide in 0.75 liter of solution? So to do this, we're going to take our 0.20 moles divided by 0.75 liters, because we want mole per liter. And we do the math and we get this as 0.27 mole per liter. So this works out to be 2.66 sorry, 0.266 6 blah blah blah, which is then 0.27. Okay, and one more, which is sucrose here in the can of cola soft drinks. Cola soft drinks have a sucrose concentration of 11 grams per 100 milliliters. What mass of sucrose is present in 355 milliliters? Well, this is our unknown. And now we have a ratio, so 11 times 355 over 100 equals 39 grams, and that's our answer. Oops. So, to review, you need to know what M represents, and that's your molar mass. Little n is the number of moles, and little m is your gram weight. Okay, and the basic formula, the molar mass equals your mass divided by your amount. So your amount is N and your mass is M. Molecular formula shows the actual number of atoms in each element in a molecule of a compound. Example, C6H12O6. The empirical formula is the simplest formula and only shows the relative number of moles of each type of an atom in a compound. So this CH2O is an empirical formula. Now, let's take a look at this question. Now, keep in mind the U just means the atomic mass unit. So we've been using M for mass. U is another way of saying the same thing, but in a more general term. Okay. So, sulfur dioxide can be used in preserving fruits and vegetables. Determine the percentage composition by mass of each element in SO3. So, from the periodic table, you find that sulfur, so the mass of sulfur, which is this little part here. Let me just grab my tool, okay. Is 32.10 times 1 atom, which is 32.1. The mass of O, which is the mass of oxygen, is 16 times 2, which is 32 atomic units, mass units. So the total, if we add up, is equal to 64. So the percent of sulfur is 32.10 divide by 64.10 times 100, which is 50.08. And the percent of oxygen is 32 divided by 64 times 100, which is 49.92. What accounts for the difference is in the rounding. So the percentage composition of sulfur dioxide is 50.08% sulfur and 49.92% oxygen. Now, continuing on, number 3. What is the empirical formula? Of a compound whose percentage composition is found to be 2.20% hydrogen, 26.7 carbon, and 71% oxygen. Again, we're going to find M, which is the mass. 2.2% times 100 grams is 2.2 grams because it's percentage. The mass of carbon is 26.7% times 100, which is 26.7. And the amount of oxygen, 71% times 100. So oxygen is 71.1 gram. The molar mass of hydrogen is 1.1 gram per mole from your periodic table. The mass of carbon is 12.1 grams per mole from your periodic table. And the mass of oxygen is 16 grams per mole given by your periodic table. So our formula to find the number of moles, take the weight times 1, divide by your M, molar mass. And that works out to 218. Repeat that step for carbon. So 26.7 times 1 mole divide by 12.01. And you'll get 2.22 mole. Repeat for oxygen, and you will get 4.44 mole. So the molar mass of H to C to O is 2.18 to 2.24 to 4.4. Now you divide each term by the lowest ratio, which is 2.18. And so you find the molar mass as 1 to 1 to 2. So the empirical formula is HCO2. Next, we're going to look at a molecular formula question. So in this question, we have the compound was found to contain 10% carbon, 89% chlorine, and 0.8% hydrogen by mass. If the molar mass is 119.6, calculate its molecular formula. So again, you want to find the amount for each element. So N, the number of moles, is 0.84. The M is the mass of carbon is 10.6. The molar mass of carbon is 12 grams per mole. And chlorine is 89.10. And the molar mass 35.5. And next we have hydrogen at 0.84. This is coming from the percents, of course. The molar mass is 1.1. So the number of moles of chlorine is 2.51. Nitrogen is 0.83. So we have the molar of C to Cl to H is 0.84 to 2.51 to 0.83. and that works out to be empirical formula mass of 119. So take your molar mass, divide by your empirical formula mass, and it's equal to 1. So that gives you your molecular formula. And that ends lesson 12.